first speaker this morning is a real superstar royalty of astronomy and cosmology. And Martin Rees, whose full title is Baron Rees of Ludlow, is going to be talking to us about our future selves. Yesterday we heard about how chemistry and physics might have gotten us here. Today, Martin is going to help us think about where we're going in the future. So, Martin, the floor is yours.
Thank you, Jill. Hello, everyone. We now know that there are planets orbiting most stars in the galaxy, billions of potential young Earths, which are habitable. And as Lisa said yesterday, there's a realistic prospect that in a decade or two, we'll have the capacity to detect biosignatures, non-equilibrium atmospheric chemistry, vegetation, etc. But of course, what is most interesting of all would be some technosignatures, electromagnetic transmissions, there's evidence of intelligence, or perhaps manifestly artificial artifacts exist. I'm going to speculate about the prospects with diffidence because I'm not an expert. And indeed, I think that science fiction writers can teach us most. But if intelligence emerged on another Earth-like planet, we've no idea of its nature or motives. So in the first part of my talk, I'm going to offer conjectures on our Earth's future, where at least we know something about the psychology of the dominant species, and where we can make informed guesses about future technological trends. But I'll start with the cosmic cameo shown on this first slide. Suppose aliens existed and that some have been watching our planet for its entire 45 million centuries. What would they have seen? Over most of that vast time span, Earth's appearance would have changed very gradually. Continents would have waxed and waned, and would the ice cover, and successive species would have emerged, evolved, and become extinct. But in just a tiny sliver of Earth's history, the last 100 centuries, the patterns of vegetation would have altered much faster than before. This signaled the start of agriculture and then urbanization. And these changes accelerated as human populations increased. Then there were even more fast changes. Within just a century, the amount of carbon dioxide in the atmosphere began to rise abnormally fast. There were anomalous radio emissions. And something else unprecedented happened. Rockets launched from the planet's surface escaped the biosphere completely. Some were propelled into orbits around the Earth. Some journeyed to the moon and other planets. We on this Earth are getting more conspicuous. If the hypothetical aliens continue to keep watch over us, what might they witness? Will a final spasm be followed by silence? Or will the planet's ecology stabilize? Or will an armada of rockets launched from the Earth spawn new oases of life elsewhere? We don't know. I'm trying to forward my slides if I can. Yes. In a recent book, now out in paperback, if I can advertise it, I ventured some predictions for the rest of this century. And this is indeed a very special century. Our Earth has existed for 45 million centuries, but this is the first one where one species, ours, has the future of the planet in its hands and determines what happens. But even with a cloudy crystal ball, we can predict some things. One is that by mid-century, the world will be more crowded. 50 years ago, the world population was about 3.5 billion. It's now about 7.8 billion. And the growth's been mainly in Asia and Africa, as you can see on this distorted map, where each country is given a size related to the population growth in the last 30 years. The number of births worldwide peaked a few years ago and is actually going down in most countries. Nonetheless, the world population is forecast to rise to about 9 billion by mid-century. That's partly because most people in the developing world are young. They're yet to have children and they live longer. The histogram on the left in West Africa will turn into something more like the one on the right, as most young people no longer die young. And the continuing growth is also partly because the birth rate does remain high in some places, rural areas of India and of sub-Saharan Africa. But despite doom-laden forecasts that were made in the 1960s, food production has kept pace with rising population. Famines still occur, but they're due to conflict or maldistribution, not overall scarcity. But to feed 9 billion by 2050 will require further improved agriculture, low-till, water conserving, and GM crops, and maybe some dietary innovations, converting insects, highly nutritious and rich in proteins, into palatable food, and making artificial meat. But to quote Gandhi, there'll be enough for everyone's need, if not for everyone's greed. And another thing, if humanity's collective impact on land use and climate pushes too hard, then the resultant ecological shock could irreversibly impoverish our biosphere. Extinction rates are rising. We are destroying the book of life before we've read it. And for many environmentalists, preserving the richness of our biosphere has value in its own right, over and above what it means to us humans. To quote the great Harvard ecologist E.O. Wilson, mass extinction is a sin that future generations will least forgive us for. So the world's getting more crowded. And there's another firm prediction, it will gradually get warmer. And that's because carbon dioxide is rising. This is the famous Keeling curve, which shows the rise over the last half century in the carbon dioxide concentration. The wiggles, incidentally, are because there are more trees in the northern hemisphere than the south. So CO2 goes up in the northern autumn and down in the spring. In contrast to population issues, climate change is certainly not under-discussed, though it is under-responded to. And the need for action was highlighted in the 6th IPC report, published just this year, and we just had COP26 here in the UK in Glasgow. But despite the uncertainties, there's one message that most would agree on. Under business as usual, we can't rule out later in this century really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland's ice. Politicians won't prioritize issues where the benefits accrue mainly to distant parts of the world and decades in the future, unless they know that the public's behind them. That's why we should welcome public demonstrations, especially from the young who will still be alive at the end of the century and whose future shouldn't be discounted. And we should be grateful to 4 rather disparate charismatic figures: Pope Francis, David Attenborough, Bill Gates, and Greta Thunberg. Between them, they've energized the world's population so politicians know that they won't lose too many votes if they respond to the action needed for climate change. But there's one win-win situation for a low-carbon future, and that's that nations should accelerate their research and development into all forms of low-carbon energy generation and into other technologies where we need parallel progress, especially storage, batteries, compressed air, hydrogen, etc., and smart grids. The faster these clean technologies advance, the sooner will their prices fall, so they become affordable to the global south, who need more energy per capita and must be enabled to leapfrog directly to clean energy, just as they leapfrogged to mobile phones without ever having landlines. It would be hard to think, indeed, of a more inspiring challenge for young engineers than devising clean and economical energy systems for the world. Incidentally, Plan B, if we fail, is geoengineering, a topic in itself which I don't have time to discuss now. We should be evangelists for new technology. Without it, the world can't provide sustainable energy, nor indeed food, for the expanding, more demanding population we expect. But there's a downside. Many of us are worried that technology is advancing so fast that we may not properly cope with it, and that we'll have a bumpy ride through this century. Advances in microbiology, diagnostics, vaccines, and antibiotics offer prospects of containing pandemics and of improving food production and health. But the same research has controversial aspects. This is the influenza virus. 10 years ago, groups in Wisconsin and in Holland showed it was easy to make this virus more virulent and more transmissible. The same can now be done with coronavirus. These gain-of-function experiments should be controlled very severely, obviously. And the new CRISPR-Cas9 technique for gene editing is highly promising. But there are ethical concerns when it's applied to human embryos, and also worries about possible runaway consequences of gene drive programs, where you can make a species sterile, whether it's mosquitoes, which carry viruses, or even animals like grey squirrels, which are considered a plague in my country. These concerns about applications of biotech are fairly near term, within the next 10 or 20 years. But what about 2050 and beyond? On the bio front, we might then expect two things: a better understanding of the combination of genes which determine important human characteristics, and the ability to synthesize genomes which match these features. And in fact, the great physicist Freeman Dyson conjectured a time when children will be able to design and create new organisms, just as routinely as his generation played with chemistry sets. But if it becomes possible to, as it were, play God on the kitchen table, our ecology and even our species may not long survive unscathed. But what about another transformative technology, robotics and AI? DeepMind's AlphaGo Zero computer famously achieved world championship level in the games of Go and chess in just a few hours. It was given just the rules and learned by playing against itself over and over again. Its processing speed allowed it to complete several games every second. And it is, of course, the speed of computers going up all the time, as this diagram shows, which allows them to succeed by these brute force methods. AI can cope with complex, fast-changing networks, traffic flows, and electric grids. The Chinese could have an efficient planned economy that Marx could only dream of. And AI can help science too. Perhaps it can find the recipe for a high-temperature superconductor, or settle whether string theory really describes our universe. Already it's been important in studying protein folding. But with limitations. Learning about human behavior, learning common sense, involves observing real people in real homes and workplaces. And the machine would feel centrally deprived by the slowness of real life. It's like watching trees grow is for us. So it's hard to teach common sense to the robots. And they're still clumsier than a child in moving pieces on the real chessboard, although sensor technology is advancing fast. And the Go playing computer used hundreds of kilowatts of power, but the brain of Mr. Lo Kui, the human challenger, there he is, uses about 30 watts, about the same as a light bulb. And he can do lots of other things apart from just playing Go. But let's look still further ahead to the speculative future. What if a machine developed a mind of its own? Would it stay docile or go rogue? Popular cultures portray a dark side, where AI gets out of its box, infiltrates the Internet of Things, and pursues goals misaligned with human interests, or even treats humans as an encumbrance. Some AI pundits take this scenario seriously, but others, like for instance Rodney Brooks, inventor of the Baxter robot, regard these concerns as premature. He thinks it'll be a long time before artificial intelligence need worry us more than real stupidity. But be that as it may, it's likely that society and the labour market will be transformed by autonomous robots, even though the jury's out on whether they'll be idiot savant, vulnerable to breakdowns, or whether they will indeed display superhuman capabilities. The futurologist Ray Kurzweil argues that once machines have surpassed human capabilities, they could themselves design and assemble a new generation of even more powerful ones, an intelligence explosion. He wrote a book called The Age of Spiritual Machines, where he predicted that humans would transcend biology by merging with computers. In old-style spiritualist parlance, they would go over to the other side. But he's worried that his nirvana may not happen in his lifetime. So he wants his body frozen until that time's reached. There's a company in Arizona that will freeze and store your body in liquid nitrogen until immortality is on offer. You can then be resurrected or your brain downloaded. I was surprised to find that 3 academics in England had gone in for cryonics. I was glad they were from Oxford and not from my university. I told them I'd rather end my days in an English churchyard than in an American refrigerator. But of course, research on aging is being seriously prioritized. But will the benefits be just incremental, or is aging indeed a disease that can be cured? Indeed, some American billionaires have just set up special laboratories called Altos Labs to spearhead this effort. I guess when these people were young, they wanted to be rich. Now they're rich, they want to be young again. And that's not quite so easy to achieve. And of course, dramatic life extension would plainly be a real wild card in population projections with huge social ramifications. But it may happen along with human enhancement in other forms. Surely on the cards, that human beings, their mentality and their physique may become malleable through deployment of genetic modification and cyborg technology. Moreover, this future evolution, a kind of secular intelligent design, would take only centuries, in contrast to the thousands of centuries needed for Darwinian evolution. This is a game changer. When we admire the literature and artifacts that have survived from antiquity, we feel an affinity across a time gulf of 2,000 or 3,000 years with those ancient artists and their civilization. But we can have zero confidence that the dominant intelligences a few centuries hence will have any emotional resonance with us, even though they may have some algorithmic understanding of how we behaved. For the rest of this talk, I'll turn to space, because it's beyond our Earth, in environments hostile to humans, that cyborg and AI technologies have the most spectacular scope, where these changes will happen fastest and should worry us less. We depend on space, of course, every day for sat-nav, environmental monitoring, communication, and so forth. And of course, space exploration has given us close-ups of all the planets and most of their moons. But let's remember that space probes like Cassini, which sent back pictures of Saturn and its moons, and Rosetta, which sent back a picture of a comet, and New Horizon, which sent back pictures of Pluto, about 12,000 times further away from us than the moon is. All these were last century technologies. Think back to the computers and mobile phones of the 1990s and realize how much better we could do today. So during this century, the whole solar system, planets, moons, and asteroids, will be explored by flotillas of tiny robotic craft. The next step will be deployment in space of robotic fabricators, which can build large structures. For instance, giant successors to the James Webb Telescope with huge gossamer thin mirrors assembled under zero gravity. These will further enhance our imaging of exoplanets and the wider cosmos. Well, what will the role for humans be in this future? NASA's Curiosity traveled very slowly across a Martian crater because it had to report back to base on Earth when it encountered an obstacle to be told how to move. Its successor, which was Perseverance, which was landed on Mars this year, has enough AI to be able to work its way around obstacles so it can move faster. And its successor may have enough AI to be able to decide which is a especially interesting place geologically to study and perhaps take a sample. Because the cost gap between humans and robotic missions remains huge, but the actual capability gap is going to narrow. And that therefore means that the practical case for human spaceflight, at least beyond low Earth orbit, will get ever weaker with each advance in robots and miniaturization. NASA's human program, ever since Apollo, has been financially constrained and has been impeded also by public and political pressure into being exceedingly risk averse. The space shuttle failed twice in 135 launches. Adventurers or test pilots would willingly accept this level of risk, less than 2%. But the shuttle had unwisely been promoted as a safe vehicle for civilians. So each failure caused a national trauma in the US. And because of this continuing safety culture, NASA will confront political obstacles in achieving any grand goal within a feasible budget. China has the resources, the dirigist government, and maybe the willingness to undertake an Apollo-type program. If it wanted to assert its superpower status by a space spectacular and to proclaim parity with the US, it would need to leapfrog rather than just rerun what the Americans did more than 50 years ago, this moon landing. A clearer cut great leap forward would involve footprints on Mars, not just on the moon. And these were the last humans on the moon in 1972, Kieran and Schmidt. But leaving aside the Chinese, I think the future of human spaceflight lies with outfits like SpaceX and Blue Origin. These ventures, bringing a Silicon Valley culture into a domain long dominated by NASA and a few aerospace conglomerates, have innovated and improved rocketry, in fact, faster than NASA or ESA has done. And if I were an American, I would not support NASA's human program. I'd argue that inspirationally led private companies should front all human missions as cut-price, high-risk ventures. There would be many volunteers accepting high risks, some perhaps even accepting one-way tickets, driven by the same motives as early explorers, mountaineers, and the like. And the phase space tourism should be avoided. It lulls people into thinking that such ventures are routine and low risk. And if that's the perception, the inevitable accidents will be as traumatic as those of the space shuttle were. These exploits must be sold as dangerous sports or intrepid exploration. But if that happens, then by 2100, the end of the century, some thrill seekers and adventurers may have established bases independent of the Earth, probably on Mars or maybe on asteroids. And Elon Musk says he wants to die on Mars, but not on impact. He's now 50 years old, so 40 years from now, he might make it. It's a realistic goal and alluring, at least to some. But don't ever expect mass emigration from Earth. Here I disagree strongly with Musk. It's a dangerous delusion to think that space offers an escape from Earth's problems. We've got to solve them here. Coping with climate change may seem daunting, but it's a doddle compared to terraforming Mars. No way in our solar system offers an environment even as clement as the Antarctic, the top of Everest, or the ocean bed. There's no planet B for ordinary risk-averse people. But we and our progeny here on Earth should cheer on the brave adventurers who venture to Mars, because they'll have a pivotal role in spearheading a post-human future and determining what happens in the 22nd century and beyond. And this is why the pioneer explorers will be ill-adapted to the Martian habitat. So they will have a more compelling incentive than those of us here on Earth do to redesign themselves. They'll harness the super powerful genetic and cyborg technologies that will be developed in coming decades. These techniques will, one hopes, be heavily regulated on Earth on prudential and ethical grounds. But the settlers on Mars will be far beyond the clutches of the regulators. Surely wish them good luck in modifying their progeny to adapt to this hostile alien environment. And this might be the first step towards divergence into a new species, spearheaded by these crazy guys on Mars. Indeed, it's these spacefaring adventurers, not those of us comfortably adapted to life on Earth, who will spearhead a post-human era. Organic creatures need a planetary surface environment. But if post-humans make the transition to fully inorganic intelligences, they won't need an atmosphere. And they may prefer zero-G, especially for constructing massive artifacts. So it's in deep space, not on Earth, nor even on Mars, that non-biological brains may develop powers that humans can't even imagine. There are chemical and metabolic limits to the size and processing power of organic brains. Maybe we humans are close to these already, but no such limits constrain electronic computers, still less perhaps quantum computers. So by any definition of thinking, the amount and intensity of thought that's done by organic human type brains will be utterly swamped by the future cerebrations of AI. We are perhaps near the end of Darwinian evolution, but technological evolution of intelligent beings is only just beginning. And importantly, it will happen fastest away from the Earth. Few doubt, incidentally, that machines will gradually surpass or enhance more and more of our distinctively human capabilities. Disagreements are mainly about timescales. Ray Kurzweil and his ilk say it'll be just a few decades. The cautious among us may say it'll take centuries. But either way, the timescale for these advances are but an instant compared to the timescale of the Darwinian selection that's led to humanities. And more relevantly, they are less than a millionth of the vast expanses of cosmic time lying ahead. We're all familiar with this time chart of the 4 billion years that's led from the first organisms on Earth to us. We tend to think that we humans are the culmination, the top of the tree, but of course that's not the case, because astronomers know that the Earth is less than halfway through its life, and the universe itself has still more time ahead of it, indeed, maybe an infinite future. And to quote Woody Allen, eternity is very long, especially towards the end. So, given this time scale and the greater rapidity of technological evolution and Darwinian evolution, the outcomes of future evolution could surpass humans by far more than we intellectually surpass slime mold. What about consciousness? Philosophers debate whether consciousness is special to the wet organic brains of humans, apes, and dogs, or does it develop emergently in any complex system? We don't know, but it might be that electronic intelligences, even if their intellect seems superhuman, still lack self-awareness or inner life. Some say it's irrelevant and semantic, like asking whether submarines swim. But I don't think it is. The question of whether these future entities are conscious affects how we react to the far future scenario I've sketched. If the machines are zombies, we would not accord their experiences the same value as ours, and the post-human future would seem bleak. But if they are conscious, we should surely welcome the prospects that they take over. Even if life had originated only on the Earth, it clearly need not, on these scenarios, remain a trivial future even of the entire galaxy. Humans and their descendants could jumpstart a diaspora whereby ever more complex intelligence spreads through the galaxy, far transcending our limitations. And the sphere of influence, or as some would envisage, a frontier of conquest, could encompass the whole galaxy, spreading via self-reproducing machines, transmitting DNA, or instructions for 3D printers, or such like. The leap to neighboring stars is just an early step in the process. Interstellar voyages, even intergalactic voyages, would hold no terrors for near immortal electronic entities. But the great question, of course, is ET out there already, or are the stars awaiting immigration, the descendants of those on Earth? This is a key question. We all agree that we don't know. Well, not all, because I'm sure many of us get letters from people who've met the aliens or been abducted by them. And I think that if you do, you should follow my advice and get these people to write to each other and not back to us. So there are people who think they know that aliens exist, but most of us are entirely agnostic about this question. It could be that for intelligence to emerge requires such a rare chain of events, like winning a lottery, that it's not happened anywhere else in our galaxy. And that will disappoint SETI searchers. But suppose we are not alone. What evidence will we expect to find? Suppose that there are indeed many other planets where life began, and that on some of them, Darwinian evolution followed a similar track to what's happened here on Earth. Even then, it's highly unlikely that the key stages will be synchronized. If the emergence of intelligence and technology on a planet lags significantly behind what's happened on Earth, because the planet's younger or because the natural selection took a different path, then that planet would plainly reveal no evidence of ET. But around a star older than the sun, life could have had a head start of 1 billion years or more. The history of human technology is measured in millennia at most, and it may be only 1 or 2 more centuries before humans are overtaken or transcended by inorganic intelligence, which will then persist, continuing to evolve on a faster than Darwinian timescale for maybe billions of years. So, in this perspective, on the time chart, organic human level intelligence could be generically just a brief interlude between pre-technology and the era when the machines have taken over. Both those could be billions of years in duration. And that therefore means that if alien intelligence had evolved similarly, we'd be most unlikely to catch it in the brief sliver of time when it was still embodied in that form. So if SETI succeeded, it would more likely reveal a byproduct or even a malfunction of some super complex machine far beyond our comprehension. The progeny from a planet which had a head start over the Earth. And indeed, the habit of referring to alien civilizations may be too restrictive, because the civilization denotes a society of flesh and blood individuals. In contrast, ET might be a single integrated intelligence. And I think we must therefore drastically reinterpret the Drake equation. The lifetime of an organic high-tech civilization, which is what's normally thought by the number in the Drake equation, may be millennia at most. But the electronic diaspora could continue for billions of years. And this vast time span should make us more optimistic about a successful SETI search for some kind of artificial artifacts. But does this aggravate the Fermi paradox? Not necessarily. Some who address this, for instance, Olson, imagine that alien civilizations will be expansionist and aggressive. But even though Darwinian selection has favored intelligence and aggression, post-human evolution, occurring via secular intelligent design, need not be aggressive or expansionist. Moreover, even if a flesh and blood civilization lasts only a few millennia, its progeny could last for 1 billion years or more, maybe just leading contemplative lives. Needing neither gravity nor an atmosphere, they would probably not be on planets. A flesh and blood civilization may be detectable for a few thousand years, but its electronic progeny and artifacts could survive for billions of years. The focus of SETI has, of course, been on the radio part of the spectrum and to a lesser degree on the optical. But of course, in our state of ignorance about what might be out there, we should clearly explore all wavebands and also be alert for other evidence of non-natural phenomenal activity. We might seek evidence for artificially created molecules such as CFCs in an exoplanet atmosphere, or else for massive artifacts such as Dyson spheres. And it's worth looking for artifacts within our solar system. Maybe we can rule out visitations by human-scale aliens, but if an extraterrestrial civilization had mastered nanotechnology, transferred its intelligence to machines, the invasion might consist of a swarm of microscopic probes, which could have evaded notice. And it's, of course, worth keeping an eye open for especially shiny or oddly shaped objects lurking in the asteroid belt. I'll end with a few speculations on the even further distant future, beyond the evolutionary stage that any aliens could have reached in the present galaxy. So let's fast forward, not even for a few millennia, but for an astronomical timescale, millions of years, millions of times longer than that. The ecology of stellar births and deaths in our galaxy will proceed gradually more slowly until jolted by the environmental shock of an impact with Andromeda, maybe 4 billion years hence. And here's a simulation of that. In fact, it wouldn't destroy the solar system, but it would just leave us living in an elliptical galaxy, not a disk galaxy. And the debris of our galaxy and Andromeda and their smaller companions within the local group will therefore aggregate into one amorphous galaxy. But distant galaxies will move further. Prima Dyson, Seth Lloyd, and Lawrence Krauss have all written on this. All the atoms of abundance in stars and gas could be transformed into structures as intricate as a living organism or a silicon chip, but on a cosmic scale. That would need, of course, a node and lattice architecture to minimize the time lags due to the speed of light. Some science fiction authors envisage stellar scale engineering to create black holes and wormholes, concepts far beyond any technological capability that we can envisage, but not in violation of these basic physical laws. And even the mass energy in the local group isn't the limit. It's consistent with physical laws to lasso more distant galaxies before they accelerate over the cosmic horizon, pulling them in to build up a segment of a Einstein static universe, where the mean density is such that cosmic repulsion just balances gravity. And some final thoughts. All I've said now is consistent with the laws of physics as we now understand them and the cosmological models as we understand them. And it assumes that the repulsive force causing cosmic acceleration, the so-called dark energy, persists. But we should surely be open-minded about the possibility that there's much we don't understand. Human brains have changed little since our ancestors roamed the African savannah a few 100,000 years ago and coped with the challenges that life then presented. It's in fact surely remarkable that those brains, which haven't changed very much, just as human nature hasn't changed very much, have allowed us to make sense of the quantum and the cosmos, far removed from the common sense everyday world in which we evolved. Scientific frontiers are advancing fast. Answers to many current mysteries will surely come into focus. But we may sometime hit the buffers. There may be phenomena crucial to our long-term destiny that we're not aware of, any more than a monkey comprehends the nature of galaxies. So physical reality could encompass complexities which neither our intellect nor our senses can grasp. Some electronic brains may have a quite different perception of reality, nor can we predict or understand what their motives might be. That's why we can't assess whether the so-called great silence signifies their absence or simply their preference. So, to conclude, conjectures about advanced or intelligent life are far more shaky, of course, than those of organic or biological. Secondly, they'll probably not remain on the planet where their biological precursors lived. But thirdly, we won't be able to fathom their intentions or motives. Thank you very much for listening.
Oh, Martin, thank you so much for a brilliant talk. And I forgot to announce before the talk that people should be putting their questions in the Q&A part of the Zoom presentation. So I'm going to take the chair's prerogative to ask you a question, which is, would Lord Rees rather be alive now and being part of the process of discovering all of these things about the universe, or would you be more comfortable in the future electronic diaspora?
I think with the present. I mean, obviously, those of us who have comfortable lives are in a world to which we're well adapted, and we hope, I certainly hope, that genetic modification and things like that will be restrained so that this planet to which we are well adapted will remain habitable by people who remain human. So I hope to remain a human, and of course, being electronic is something so different that we can't imagine it at all. So I think we should not necessarily think that this progress in processing power of of artificial brains, etc., is the same as sort of progress in a way. We may prefer, just like if you were to ask, say, an eagle, would it prefer to be a human being? It may say it wouldn't. It enjoys having the powers which a bird has, which we don't have. So I think we just realize that it's not just a single parameter of intelligence. And just as I'm happy to be a human, we can well imagine that other entities, although far below the peak in intelligence, would be happy to be as they are.
Oh, thank you. Actually, Jordan Stone wants to continue with that idea about how far in the future do you think we can consider ramifications before the uncertainty is too great?
Well, I think it depends on what aspects. I mean, some technologies, of course, we can't predict more than 10 or 20 years ahead. But of course, some things like the configuration of the solar system is not going to change for 1 billion years. So I think it depends exactly what we are thinking about. But I think we've got to bear in mind that the uncertainty clearly gets greater. And incidentally, it's easier to predict the direction of change than its speed. Let me give you a couple of examples. It was only 12 years from Sputnik 1 to Neil Armstrong's one small step, but then 50 years, no more probes in manned spaceflight. And to take another example, it was 50 years from the first transatlantic flight by Alcock and Brown and the Boeing 747 coming into service. And that has been in service for more than 50 years with hardly any change. So what so often happens is there's a burst of rapid change and then things level off and some new technology then develops fast. And for that reason, although smartphones have pervaded the world far more quickly than many of the experts predicted, then of course they may level off. The iPhone 20 maybe not too different from the iPhone 13, but then some new technology, maybe biology-based, will take over. So we can't predict the speed, the surges or the stagnation periods, although we can predict the direction of change.